So in order to understand this technique, you're going to need to first understand clumativity and how it applies to clock. Clumativity is defined as A plus B equals B plus A. Now how does this apply to clock? Why, it's quite simple. In official WCA scrambles, as I'm expecting you to know, there is a fixed pin order. But you can actually do this pin order in any order you want, as long as you do the same turn as what it's told for each pin arrangement. So let's give a quick example. Let's say we'll do UR is 1, UL minus 1, U pins 6. There we go. This is the case we get. Now let's do a different order of those. All the U ones, 6. Minus 1 on UR, minus 1 on UL. Sorry, I got those mixed up. But anyway, I did UL then UR. And look, it's the same case. I did the same sort of turn on each pin arrangement. Minus 1 for UL, plus 1 for UR, and 6 for U. Now I'm not going to go through all 6 combinations I can do of those pin arrangements, but it shows the point. It doesn't matter what order you do them in. Now how is this the case? Now I'm going to explain this. You're going to need to think about a clock a bit more abstractly. So, if we instead of having 9 clock faces, we're only going to focus on the front face at the moment. We'll ignore the back for this. And also, yeah. So, we've got 9 numbers now, and with the numbers 1 through 9, numbering these clocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can associate a number with it. Now that number is going to be whatever the time is on the clock. We're going to call 12 o'clock 0, because now we can use modulus 12. Now what mod 12 is basically counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And instead of going to 12, it goes back to 0 again. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, so I said 12 there, I mean 11, 1. Wait, getting this mixed up. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And a clock is a good visualization of this because we'll put all the clocks now to 11 o'clock. Now if we add 2, what do we get? Well, 11 plus 2 is 13, but in mod 12 it's 1. Because as you can see, it sort of goes back and starts again. But anyway, so now that we've defined these two things, now we need to define what each pin arrangement does. So let's say when the URL pin is up, we say, oh, we add whatever the turn is to whatever number clock it is. So in this case, 1, 2, 4, 5, and then we do that for every possible pin arrangement. So all the ones with 1, all the ones that have 2 up, whether it be in a line or even diagonally, whatever, all the pins being up. Yeah, we're not going to focus on when the pin's down, what that means yet. But anyway, so now when we think about it in that way, we can break a scramble down into such a way that explains this quite nicely, clumativity nicely. So, if we focus on just one clock, let's say the first clock here, the one that we labelled as 1, and what happens to it during the scramble with each pin arrangement, of course there are all the ones that doesn't affect it at all. So we can just say, so we'll call each pin arrangement and that a move. So that's 2 moves. So, in that case, when we do the move with this pin, that's 0, plus 0, plus 0, plus now whatever we turn here, and so on. So let's just focus on the 2 pin arrangements that actually move this clock. So that's when this pin is up and when both these pins are up. So we'll get turned something, and then we'll get turned something else. And of course we need to add those 2 numbers together. In the case of where it says minus, we can just think of that as 9 instead of minus 3, or you could just, add a negative number to it, but whatever. So let's say that, we'll just do some random moves here. Of course, here's the first time it gets affected. Let's say minus 3. That was minus 2. 1. So minus 3 is 9, and minus 2 is 7. And then we just added 1. So if we think about it in that way, what we did first is we did minus 3, which takes us to 9. Then we did minus 2, which would take us down to here. Let's just focus here. So it starts off here. So with that scramble, what we did is minus 3, minus 2, 1. Now, so yeah, what it basically then breaks down into is it just, what happens to each clock is just, each move is just effectively addition. So each move that affects the clock, we just add a number, and then we add another number, and so on. So, what you may know is that if you have a whole bunch of numbers you need to add together, it doesn't matter what order you add them in together, you're going to get the same result in the end. So, that is why you can change the pin order to be any arrangement you want on a clock. So, yeah, in a more practical case, if we actually do a solution here, it's quite a simple one, what we notice here is that we can move this 3 moves and it will be matching with this. So we have 3/4 of the edges solved, and it will then need to match this up, match weight this, and then of course we'll need to match up with the last one. But instead what we could do is 4, which would be the second move I was showing, and like so. Of course that was an easy enough case that you can quite easily see either possible solution, even though it's technically the same solution. But for slightly more complicated ones, where nothing's matching up, like so, we can match, like we match this one up. Oh. Match this one up. Okay, that wasn't a good example because those are linked up together. Yeah, but for a case, you know, I've matched that up. Okay, whatever. You get the point. You can do the turn of that with 2 pins up whenever you want in the solution, assuming you know you can you know the solution from inspection well enough that you're like, oh, I have this pin arrangement followed by this pin arrangement followed by this pin arrangement, and you know how many turns you need to do for each one. So now let's just quickly focus on what T-layer turns do. It turns the corner for all the down pins, and only the corners. Except no, that's not the case. Because it's turning the edges, because when you flip the clock, the pins are up, and now it turns all the adjacent edges around it. So this is something you should know. Now, old WCA notation was different for scrambling. Can't remember exactly when they changed it, but it was slightly different. So, the way it worked with the pin arrangements is it started off with the pins being up here and down here. It was also written differently, but anyway. So you did a layer turn on the U turn and then a turn on the D turn. You changed the pin arrangements so that only the right pins were up, and then you did a turn on the U and a turn on the D. Of course, it could be 0 being the turn, but anyway. Then the same on down, the same on left being up. Then you had all the pins up and all the pins down. So, this idea of doing 2 turns at the same time is what I'm getting to with this. Now, something you need to think about are what are compatible turns when you flip a clock over. Obviously, you can't do that many cases where you can do 2 turns at once. But anyway, let's have a look at this scramble. So I can match this one up here, or with any of them, it doesn't matter. And if we look here at what the first move is, well, we're a bit more limited. But anyway, let's just get one matching on each face. So, I need to do a 3 to match these up, and yeah. Yeah, actually no. Yeah, so here's a point. I'll set up properly. Okay, these actually match up, but we'll pretend they don't. So yeah, here's a case of a compatible move. We can turn, these 2 pins are up, and then when we flip them, these 2 pins are up. So we can do these turns both at the same time, so that this matches up there, and this matches up there. So we could go like so. The only other type of compatible move that you can see is obviously turning the whole thing around till it gets to whatever time you need. This is perhaps actually the most useful one, because when we have it here, what do you see? It turns 1. So, yeah. Right, so let's just get this till we have 3 matching up. So now we only need 3 pins to turn them all the way up. So what do we need? We need 2. Well, it's -2, but when we flip the clock, it's 2. So we know we now need to turn down 2 o'clock for this. Was it 2? Yeah, 2. So we can push this forward 2, and now let's say this is the pin we're stuck up, because if we change it, it won't affect it. But of course, since it doesn't matter which pin is down on these, we can change it to be whatever one we find most advantageous. So in this case, I think let's shift it to be that. So this goes forward 2, and this goes back 2. And look, we just managed to do 2 moves at the same time. I definitely think this concept could be useful, but I honestly think you could maybe only save, well, 2 sort of moves. In other words, there will only probably be around about 2 positions where you might be able to turn 2 layers at once during each individual cross solution for this, which of course you could mix up the order of one of them in order to be advantageous for the other. So rather than it being upwards of 8, you could get it down to like 6. I don't know if I described this very well, and I don't think this is necessarily the most useful, but yeah, so let's just go through a quick example here. So obviously that will match up like that, but let's just leave it. I'm not, yeah. So we can go da, 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 da. Get that? Yeah. Turning when it's backwards is kind of complicated. So there's another example of the 3. I'm not going to go through the 2 so much, but by manipulating the pin order, you actually solve the crossword of the more fixed pin order type things people use when solving it. You could definitely manipulate it so it's more easy for you to get there. So for example, you could do the pin order. Yeah, so for example, the standard pin order, well, the pin order Stefan Pochmann has, I believe, is that, and then, what is it? I'm not sure, I'm not very familiar with the pin orders, but I think it goes there and then there. So when that's flipped, that obviously starts only affecting this corner. And then of course it's that corner, and that. But due to the fact that you may flip it with a Y2, you can do some of those turns at the same time. I'm not so sure. X2, you sort of can as well. Well, actually, no, you can't, but yeah. Not so sure about that type of flip. But yeah. Just hope this maybe gave some of you guys something to think about.